Okay, question 8. This is going to be a more difficult type of orbital motion problem. So, a long line connecting Earth and the Moon, along a line connecting the Earth and the Moon, what distance from Earth's center would an object have to be located so that the gravitational attractive force of Earth on the object was equal in magnitude and opposite direction from that of the gravitational attractive force of the Moon on the object? Okay, so this is Earth, and this is the Moon. And the object should be located probably closer to the Moon, right? Because the Moon's pull is obviously a lot weaker than that of the Earth's. So if we want to have equal pulls on this object, like the Moon pulling on this object and the Earth pulling on this object, the object obviously has to be closer to the Moon. So from there, we can say we want to find this distance. This is the distance from the center of the Earth to the object. So it asks what distance from the center of the Earth would an object have to be located so that the gravitational attractive force of the Earth is equal in magnitude and opposite direction of that of the Moon. So we'll call this R1, the center distance 1. And we'll call this R2. So now we can say that FG Earth equals FG Moon. So G, we'll say ME for mass of the Earth times M for the mass of the object, all over R1 squared is equal to G, mass of the Moon times the mass of the object, all over R2 squared. So we come across a problem, right? We don't have enough variables to isolate for R1, but we can turn this R2 expression into that of one that includes R1. So how are we going to do that? Well, we can say that R2 equals Rm minus R1. So what is Rm? Rm is just the center to center distance of the Earth to the Moon. So this distance, so Rm minus R1, that equals R2. So let's label this Rm. Therefore, now we finally have enough variables to solve for R1. So we can say G, mass of the Earth times the mass of the object, all over R1 squared, is equal to G, mass of the Moon times the mass, all over Rm minus R1 squared. Okay, so now we can just cross multiply. So G, mass of the Earth times the mass of the Moon times Rm minus R1 squared is equal to the G times mass of the Moon times the mass times R1 squared. Let's divide both sides by G by this expression. So we end up getting G, mass of the Earth, Moon, object all over G, mass of the Moon times the mass of the object. We can cancel out these G's, and we can say that is equal to R1 squared all over Rm minus R1 squared. We can square root both sides, and that leaves us with root mass of the Earth over the root of the mass of the Moon. That is equal to R1 over Rm, that being the center of the Earth to the center of the Moon's distance, minus R1. Okay, so from here, let's cross multiply again. So root Me times Rm minus R1, that is equal to R1 times root MM. Now let's FOIL this root Me out. So root Me times Rm minus root me times r1. And that is equal to r1 times root m. Okay, so we want to isolate for r1, so let's bring this expression to the right. So root me times rm is equal to r1 times root mass of the moon plus root mass of the earth times r1. So root me times rm is equal to common factor in r1, so r1 and then root mass of the moon plus the mass of the earth. From here we can divide both sides by this expression and we're pretty much done, right? So r1 equals root mass of the earth times rm being the center to center distance of the earth and the moon all over root mass of the moon plus root mass of the earth. Okay, so we can move this up here and say r1 equals, so we go to our appendix B for the mass of the earth. So that's 5.98 times 10 to the 24. So r1 is equal to the root 5.98 times 10 to the 24th times rm. So rm is the center to center distance of the earth and the moon, otherwise known as the mean radius of the moon's orbit. So this guy, 3.84 times 10 to the 8th. So times 3.84 times 10 to the 8th, and then all over the mass of the moon. So mass of the moon, this guy, 7.36 times 10 to the 22nd, the earth. So plus 5.98 times 10 to the 24th. And put that all into your calculators and you should get a value of 345,653,218.4 meters, right? I forgot to put the units, but if you were to cancel them all out, you'll end up with meters. So that is how far we must place an object away from the center of the earth in order for the moon and the earth to share equal gravitational effects on this object. So as you can see, this is a lot farther from the earth than it is from the moon to the object.